Good morning, children. How are you all? I hope you are all fine and regular in your studies. Now, welcome back to our chemistry classroom. This is the last session of our chapter. In the last class, we have discussed about the interconversion of states of matter, isn't it? So, this was what we discussed in the last class, interconversion. You have also studied that for this interconversion to occur, certain conditions are required. And what did we see? Yeah, change in temperature. Change in temperature was the first condition, and we discussed about this change, how change in temperature result in the interconversion of the states of a substance in detail in the last class. So, today let us see how change in pressure is going to affect the interconversion. You have already studied the particular arrangement according to kinetic theory in gases. How was it? Yeah, the particles lie very far apart in a container. The particles of a gases, they lie very far apart. So, when pressure is applied to this container, or when pressure is increased and temperature is decreased, we can see that these particles, they will be coming little more closer, or that is the substance is changing from gaseous state to liquid state. This is how, when we increase the pressure of a gaseous system, what is going to happen, and when the temperature also should be decreased or it should be cooled down, then the substance will be changing from gaseous state to liquid state. That is, their particles that was lying far apart will be coming some more closer. Then on further increase of pressure and further cooling, we can say that the particles will be coming little more closer, and the liquid state will be changing. So that is the result or effect of change in pressure. Let us see some examples. You are all familiar with the LPG cylinder which we are using at home, isn't it? So what is in that container or in that cylinder? Liquefied petroleum gas. That is actually LPG. You know that it is in gaseous state. Actually, under normal condition, the LPG is gas. So the cylinder which is delivered to home, in that actually LPG is stored under high pressure in that cylinder. Thus it is in liquid state, and when we open the valve or when the cylinder is connected to the stove at kitchen, actually when that valve is opened, the pressure will be released in controlled manner. That means the liquid LPG will be converted into gaseous state and slowly released through that pipe in a controlled way. That is how we are able to light the stove and use it for cooking. Then another example which have you heard about? Liquid air. In certain cases we are using liquid air. You know air, the constituents of air. You have already studied it in previous classes. The majority or the major content of air is nitrogen. The gas nitrogen and oxygen. So they are actually under high pressure cooled down to get liquid air. That is the second example of this interconversion under increased pressure. Now let us look at the diagrammatic representation of interconversion of states of pattern. Let us see these terms one by one. I think you are familiar with these terms. See, the process of conversion of a substance from solid state to liquid state, what we call that? That is known as melting. And see, the temperature at which a substance starts to change its state from solid to liquid, that temperature we call as melting point. And for example, let us consider the solid substance ice, and the temperature at which the solid substance ice begins to change into its liquid state. Liquid state means water. That is known as the melting point. So what is the melting point here? Do you know melting point of ice? It is 0 degrees Celsius, isn't it? Now, the next term here is evaporation. What is that process? Evaporation? Yes, tell me. The process of conversion of a substance from liquid state to gaseous state, that is known as evaporation. Evaporation is a well-known phenomenon which we are observing in nature. You know that the water from rivers, seas, etc. evaporates daily, isn't it? You have studied about water cycle, and in that you have seen this term evaporation. So evaporation is the process of conversion of a substance from liquid state into gaseous state. So when we are considering the example water, from the water in liquid state to vapor in the gaseous state. So the temperature at which the substance begin to change its state from this liquid state into gaseous state is known as boiling point. So boiling point means the temperature at which the water begins to change its state into vapor. What is the boiling point of water? Yeah, you are very familiar. Boiling point of water is 100 degrees Celsius. So when we are boiling a bowl of water, see, the temperature will remain constant during the conversion of the whole entire bowl of water into vapor state. Only after that there will be change in the temperature. So continuously when we are boiling a bowl of water, this temperature will be remaining constant throughout till the whole bowl of water is converted into gaseous state. And at this boiling point, the pressure, what about the pressure? The pressure of this liquid will be equal to the atmospheric pressure. Now the next term. So the next process is the reverse process. Now we have to see the process of conversion of a gaseous substance in gaseous state to liquid state. This is known as condensation. So condensation point is the temperature at which a substance in gaseous state begin to change its state. That is, the substance in gaseous state is beginning to change its state into liquid state. For example, in the case of water, again, the vapor, the water vapor, when it is condensed, or condensing means cooling down, or we are lowering the temperature there. When it is when the temperature is lowered, the water vapor will begin to condense into liquid state. So that point, that temperature is known as condensation point. So what will be the condensation point of steam? That is again 100 degrees Celsius. Now here there is one more term which we have to study, that is liquefaction. So liquefaction is condensation itself, but it will be taking place by applying pressure. By applying pressure and lowering the temperature. So that is the slight difference in this type of condensation. Now next term or next phenomenon which we are going to see here is freezing. Freezing or solidification. Now can you say what is freezing? Yes, it is the, tell me, it is the conversion of a substance from liquid state into solid state is known as freezing. And when we consider our example of water, the water in the liquid state, the temperature at which the water begin to solidify is known as freezing point. Now what is the freezing point of water? It is again 0 degrees Celsius. So freezing means it is the process in which the substance in liquid state is converted into solid state, and the temperature at which this conversion from liquid state to solid state begins, at that point is known as freezing point. So you are well aware that the freezing point of ice is 0 degrees Celsius. Now another one process which I have written here is sublimation. Sublimation, we have already discussed. What is sublimation? Yeah, sublimation is the process of conversion of a substance from solid state into gaseous state and gaseous state into solid state directly without converting into its middle liquid state. So that process is known as sublimation. And example for sublimable substance, camphor, naphthalene, etc., which we have discussed already in the previous class. So you have to draw this diagram and familiarize all these terms. Definition, you have to study the definition. It is given very clearly in your textbook also. Now let us move on to the last topic of this chapter, that is law of conservation of mass. This law was put forward by the famous scientist Lavoisier. He stated that matter can neither be created nor destroyed. This is the important law. Matter can neither be created nor destroyed. This is the law of conservation of mass put forward by Lavoisier. This means that the total mass of the reactants, total mass of reactants will be always equal to the total mass of the products. Mass of the products in a chemical reaction. The total mass of the reactants will be always equal to total mass of the products. That is, the conversion from only one type to other type is taking place. So, the matter is always remaining there. It cannot be neither created nor destroyed. So this is the law of conservation of mass. Now we can watch the experiment to prove it. How we can prove law of conservation of mass. Now for example, let us burn a piece of wood. What can you see when you burn a wooden piece? You can obtain a handful of ashes. So can you guess the mass of that wooden piece and this ash? Will it be equal as we said here? The total mass of the reactants here what is the reactants? That wooden piece we are burning. That is the chemical reaction taking place here, and we are getting that handful of ash. So will that mass or weight be equal? No. Why is it so? Because here, see, when wood is burning, actually the wood is reacting with the oxygen present in the air. So we are not taking into consideration the mass of that air. And here also, when we are speaking about the mass of the product, we are only looking at the handful of ash with us. See, while that burning process is going on, some gaseous substance are also formed. What is that? Can you say? Yes, carbon dioxide and water vapor also will be obtained during the burning of wood, but we are not taking into consideration the mass of that gaseous product. That is why, see, when you burn a long piece of wood, you are getting only a handful of ash. But when experimentally, if we are seeing, we can prove that this law is true. That is, matter can neither be created nor destroyed. That is, the total mass of the reactants will be always equal to the total mass of the products. Let us see that.
Conservation of mass. We require measuring cylinders, barium chloride solution, sodium sulfate solution, conical flask, cork, 10 ml test tube, and an electronic balance. Measure 5 ml of sodium sulfate solution in a measuring cylinder. Pour it into a conical flask. Measure 5 ml of barium chloride solution in another measuring cylinder. Pour it into a 10 ml test tube. Tie the test tube using a thread and hang the test tube in a conical flask carefully so that the solutions do not mix with each other. Cork the conical flask so that the thread holding the test tube is firmly held in place. Take the conical flask and carefully weigh the flask on an electronic balance with all the contents, ensuring that the solutions do not mix, and note the reading. Take the flask from the balance, tilt it and swirl the flask so that barium chloride solution in the test tube spills and mixes with sodium sulfate solution in the flask and forms a white colored precipitate of barium sulfate BaSO4 and an aqueous solution of sodium chloride NaCl. Wait for 10 minutes to complete the reaction. The precipitate of barium sulfate settles down to the bottom of the flask. Weigh the contents of the flask again and note down the reading. It will be observed that the total mass of the reactants is equal to the total mass of the products. Hence, the law of conservation of mass is verified.
Different kinds of experiments, but the procedure will be the same for both. So the first thing we're going to do is we're going to find the mass of vinegar. So in order to do that, we need to contain it in the cylinder and find its actual amount. And so we have a cylinder, but we don't want the mass of the cylinder. So we're going to actually zero this out. And now we're going to add some vinegar, approximately 10 milliliters.
it doesn't have to be exactly 10, but around there is fine.
And after we do that,
Then you're going to record the mass. So since we already zeroed it out with the graduated cylinder, this is only the mass of the vinegar itself. So we're going to record that where it says mass before for the vinegar is 10.0 grams. Then you're going to take that off and set it aside for the moment.
and we're going to press 0 again. And now we're going to add a Ziploc bag onto the scale. And once again, we don't want the mass of the Ziploc bag, so we're going to press 0. And now we're going to add some baking soda. Again, it doesn't really matter exactly how much, but we're going to add some to it, about a teaspoonful. And we're going to find a mass of both. And now this is just the mass of the baking soda. So 5.8 grams. Yours might be different.
And you're going to write that number down right next to where you wrote the mass of the vinegar on the mass before line, because we haven't done the reaction yet.
Okay, now what we're going to do is we are ready now for the reaction. And we're going to zip the Ziploc bag up just a bit and have only a small section of the Ziploc bag open so that we can capture all the gas that we're going to be making here soon.
And carefully pour in the vinegar.
Quickly zip that up and let that react.
And then you're going to want to make sure the whole bag is on the scale, so you get the accurate mass of everything inside. And then you're going to write that down as your mass after the reaction. And then what you can do is add up the mass before of the vinegar and the baking soda and see if it matches your mass afterwards.
With this, we are coming to the end of this chapter. In this chapter, matter, you have studied in detail about matter as a high school student. Say the kinetic theory about matter, the interconversion of states of matter, what are the conditions required for that, everything you have studied little more deeper way. So, watch the class carefully, then study the chapter thoroughly. After that, see, I have given the questions also for you. Answer it in your notebook. The next class, next chemistry class, you will be having a test paper based on this chapter. The details will be given in your class WhatsApp group. Thank you. Have a nice day.